Hello and welcome to excelmasterseries.com. Today we're going to show how to use the Poisson distribution to solve problems and do it in Excel. Now taking a look at our Excel spreadsheet, we'd like to remove the grid lines to make it easier to read. So hit Tools, Options, Uncheck Grid Lines. Okay, grid lines are gone. And the Poisson distribution is a discrete distribution, not continuous. It's used to calculate the probability of a specified number of events over a period of time whose occurrence can be predicted by the Poisson distribution. It's used to calculate the probability of events such as product demand, demand for services, number of telephone calls over a switchboard, number of accidents, traffic arrivals, number of defects. Let's take a look at a problem that uses the Poisson distribution. Problem reads as follows. An average of 4.8 telephone calls per minute is made through a central switchboard. The occurrence of calls can be predicted by the Poisson distribution. What is the probability that A, exactly 4 phone calls will be made in a given minute? Well, the Excel formula we're going to use to solve that is 3 parameters, x, mean, and cumulative. The first parameter, x, is the value that the function is being evaluated at. The problem says, what is the probability that exactly 4 phone calls will be made in a given minute? X is set to 4 here. Second parameter is mean. Problem says an average of 4.8 phone calls are made per minute, so mean equals 4.8. Third parameter, cumulative. Are we using the cumulative distribution function or probability density function? Problem says, what is the problem of exactly 4 phone calls being made? That is the probability density function, not the cumulative distribution function. So in this case, cumulative is set to false. And we take a look at the numbers put in for those parameters in the Excel formula. The x is set to 4, mean at 4.8, cumulative is set to false. That gives us an answer of 18.2% that exactly 4 phone calls will be made in a given minute. And we see in our formula that there are spaces between the numbers in what we have here. But if we take a look at the actual formula right there, you'll see there are no spaces in Excel formulas. If we look at our interactive Excel graph, this is a graph made in Excel, very easy to make. You can make this. And if we put the cursor right above the point t equals 4, the value on the chart agrees with our calculated value from the formula, 18.2%. This is an interactive chart, and we'll give you instructions how to buy an e-manual that'll show you how to make these charts and do all these calculations in Excel. And as we said, this is interactive. If we vary the parameter, the mean, we can see that interactivity reflected in the chart. Varying mean from 4.8 to 9, we see that chart. Then back to our original 4.8 to get our original chart back. Now, if we ask the question, what is the probability that up to 4.8 phone calls are made in a given minute? We're using the cumulative distribution function. And in this case, we're setting cumulative to true. That's the only change. And in this case, this will give us an answer that there's a 47.63% chance that up to 4 phone calls are made in any given minute. If we look at our interactive Excel chart below, and we've made this chart in Excel. If we look at this chart and we put the cursor right above the point t equals 4, we see that the chart's value agrees with the value that we've calculated with the formula, that there is a 47.63% chance that up to 4 phone calls are made in any given minute. This is an interactive chart, and varying the parameter, mean, from 4.8 to 9, and we see that change reflected in the chart. And let's put it back to our original 4.8, and there's our original cumulative distribution function chart for the Poisson distribution, our Excel interactive chart. If you would like to master MBA level statistics in Excel, check out our Excel Statistical Master series of e-manuals at www.excelmasterseries.com/emanual.php. Thank you very much and goodbye.